Great, so it is 1:30 where I am in Linz, Austria. So we'll go ahead and get started. I see more people are joining every minute, but so far at this conference with the virtual setting, we've been in a bit of a time crunch with every session. So I want to give our speakers as much time as possible, and you out there, the audience, as much time as possible to ask questions of them. Welcome again. This is Focus Group 3 at EMP-E 2020, where we're discussing consumer and citizen engagement. The first thing I'm obligated to tell you is that this is being recorded for your information. And the second thing is that we are operating with participation from the Slido platform, which I'm sure you're all familiar with now, but please open up your web browser, go to slido.com and type in the code citizen, and you will come into our Slido panel for today. You can leave ideas for us and comments. You can leave questions for the speakers. We'll have a moderated panel with the last half hour of today's session. And then we can also have a post-session survey that we'll go over at the very end as well. So our session for today has 4 presentations, each about 10 to 15 minutes. And then, as I said, 30 minutes at the end for a moderated panel led by Diana Susser from the Sentinel project. Today's session is co-organized by the Smarties project, which is not a modeling project, an energy system modeling project. It is an agent-based modeling project, a social science project from Horizon 2020, as well as the Open Entrance project, which I'm a part of, and then the Sentinel project, which Diana Susser represents. So what are we trying to learn about today? First off, we're interested in citizens and consumers in the energy system and trying to figure out if they are adequately considered so far in energy system models. So the first question is, are their behaviors and preferences represented well within these models? And if not, can agent-based modeling, this bottom-up approach, which we'll talk about later, can agent-based modeling improve this representation? Finally, are citizens well integrated into the modeling and engagement process? So we had about 30 responses to a pre-survey that some of you responded to, and we'll go through that really briefly. So first off, citizen and consumer preferences and behavior are already adequately considered in leading energy system models. 1 being strongly disagree, 5 being strongly agree. We see the median here is 2, so not so much, which means that this session makes a lot of sense to be having. Second off, are we familiar with agent-based models? We see across the gamut here, many people are very unfamiliar with them, some people very familiar with them. We're going to learn a lot from some of the leading experts here from the Smarting project about agent-based models, and hopefully at the end of this, we will all be much more familiar with them. Next, agent-based models can be coupled with and add value to energy system models. We see the median here was 4, which says that everyone agrees with this idea. So why aren't they yet coupled with them? Well, there's likely some difficulties with that, which one of our experts will go over with you. Finally, agent-based models should be coupled with energy system models. We also see this as a 4, which is saying that people strongly agree with this statement, and moving forward, maybe we can see more cooperation between agent-based modelers and energy system modelers. And for our third motivation here, are citizens and consumers sufficiently engaged in the modeling process? This is saying, are they actually understanding these models? Are they using them? Are they getting to see the output and give their input into how the model is set up? We see this as a 2, which is saying people strongly, relatively disagree with this statement. So how can we do a better job of bringing citizens actually into the modeling process and developing the models? Again, before I go on, I'd like to invite you to go to slido.com, enter the code citizen to have a chance to engage with our speakers moving forward. And I will now switch over to our first speaker for the day, who is Christian Klockner. Welcome, Christian, thank you. Professor Christian Klockner is a full professor in environmental psychology at NTNU in Trondheim. He is a leading voice in the application of psychology insights into applied energy problems. especially in relation to the participation of citizens in the energy transition, and he coordinates the Horizon 2020 project Echo, Smarties, and Enchant. Christian, we're very happy to have your insights today, and the floor is yours for the next 10 minutes.
Yes, thank you. Could you please switch to the first slide? When we think about energy systems, when I think about energy systems, I'm not an expert on energy systems. I'm an expert on people, and what I show you here is kind of a network of people, which in my mind mirrors the network, the energy network, in many ways, but in many ways it doesn't. So the first question I asked myself when I was invited to give this presentation is, which roles do citizens have in the energy system? Which, next slide, please. Which are many. So usually when you think about citizens and their role in the energy system, it used to be that they were customers in the energy system. So they were buying something from the big producers, and this is energy. And that means, of course, that they are energy users. They use the electricity for their daily practices, for what they do during their everyday life. But they have also become energy producers. Some of them have solar panels on their roof, others have invested in wind energy production and so on. So there are many ways of how consumers also are energy producers, or in the future maybe also storing energy in their electric vehicles, for example. But what we also know is that citizens are interest groups and pressure groups. They are against or for different types of energy production or energy lines and whatever has to do with the energy system. So they can form quite powerful groups that interfere with the transition of the energy system, or that can foster the transition of the energy system. Sometimes citizens are also innovators, and that's what the Smarties project is all about, namely trying to find out under which conditions citizens engage in energy and energy system innovations. And that could be local things like new ways of producing energy, new ways of distributing energy, new ways of organizing mobility, and so on. And there's a last one missing, please click one more time. And that is that citizens, of course, also are voters. And as that, they also have quite an impact on how the future of the energy systems will look like. Next slide, please. When we, in the ECHOS project, a couple of years ago, went through the energy policies that have to do with energy systems, we tried to find out what kind of assumptions do policymakers have about how citizens work? So how do citizens function? And what we found was that the overwhelming focus in policy is on 2 points. One is we need to give citizens economic incentives to behave in the way that brings forward the energy system, or we need to give them information. If they don't behave like we want them to behave, it's probably because they don't know better. And then there's a little bit of other things like a status quo bias, so people like to keep things as they are, convenience, social influence, emotional reactions, trust and transparency, and all of those come in a little bit, but usually those two are strongly dominating. And this, next slide please, is in a strong contrast to what we else in the ECHOS project found are the impacts on people's energy choices. So on the individual level, on the level of people, we found that people are steered by their intentions, but also by routines and habits. So they keep doing what they have been doing before. They are affected, of course, by objective constraints, but even more so by subjective constraints, so how they experience how difficult, for example, it is to change the energy provider. It's not so much the objective difficulty, it's the subjective difficulty that decides how people behave. Then they behave in relation to their attitudes towards different types of energy production, different types of companies, and so on. But they also have personal norms and values, which are more overarching factors that influence the way people behave across different situations. So some people are more interested in saving the environment, while other people are more interested in economic prosperity, for example. And then people are affected by what other people do and say to them, which would be social norms. They also are affected by how much responsibility they ascribe themselves to changing things, changing the energy system in our case here. And they are affected by how effective they think their actions are. And they're especially the collective efficacy is interesting. So what can we achieve together as a group of people, as the group of citizens of a certain town, or as Europeans, for example? But then they also are affected by what they identify with, who they want to be, which group they want to belong to. That affects strongly which choices people take, and this impact is usually going through emotional reactions. So people make decisions based on emotional reactions and also based on all of these different factors here. And if we take now one step up on the next level, next slide, please, we look at the society around in which people are, because people are not alone. They are part of larger groups, they are part of smaller groups. And in society, you can see that the energy culture, a certain group of people or a country has an impact on how people relate to energy use, to energy systems, and so on. So you see in some countries, for example, a strong opposition towards wind energy, whereas in other countries that is not so much the case. The meaning of energy use, so what kind of meaning you ascribe to energy and what you do with it, is important. The historical events connected to energy, energy production, energy use can have quite a big influence on how an energy system develops. One example here might be Fukushima, which had a strong impact on the German energy system. Normative practices, social performance, so how do groups of people agree on what is the normal thing to do? How do we trust or distrust certain actors in the energy system? And not the least, what kind of lifestyles are we in? So what are the overall overarching patterns of behavior that we have in a society? They contribute to energy choices and how they are made. And if we even take one step further, next slide, and look at how companies, how authorities make decisions, they have more of a focus on economic performance, how policy instruments affect companies, for example, but they also have this dimension of environmental concern. What kind of infrastructure is available? How does it fit the economic interests? How does it fit environmental concerns and so on? Also, those things have an impact on how these types of actors make decisions. So we should not assume that companies make decisions purely based on economic considerations. And now going over to the Smarties project, because in the Smarties project, next slide, please, we are trying to develop models of people, models of groups of people, to see how such innovations in the energy system emerge. And these groups of people, or these systems that we simulate, they consist of different components. So we have there the local communities and their social networks. So the network of people is quite important for agent-based models. We have the energy-related social innovation as a component here. So what is it that we're interested in? For example, in one of the models, it's being connected or not connected to the local heat network. We have organizations here like the local municipality, for example, but also electricity providers, media companies, and so on, that all have their part in this local system. And these systems behave in response to policy scenarios. So what policymakers put as frameworks around them. And then there are some contextual drivers. For example, if we look at models around mobility, then of course the geography of the local community would have an impact here. Next slide, please. So what we build our models in Smarties on is, or took a starting point among other models in a HUMAT model that was developed by one group that is participating in the Smarties project. And this model has been developed further for Smarties. And one basic assumption in this model is that people have different types of needs and they make decisions to satisfy their needs. And if their needs are not satisfied, they take action to increase satisfaction of their needs. So they do something to get their needs into balance. And this has to do, the actions they take have to do with what kind of opportunities they are faced with and what kind of abilities they have. And how they decide for which types of actions to take depends on if they are quite certain about the outcomes of their actions or if they are not. So if they know this will happen if I do this, then they are certain. But if they just have never done it and try it for the first time, they don't know if it's going to work. And then there's a higher level of uncertainty. And depending on the combination of those factors, they take different strategies to satisfy their needs. Next slide, please. So we have in the center of this automatic human model that we build here in Smarties, three types of need. We have experiential needs, which is basically I want to have it nice and good right now in the moment. So for example, if I think about transportation, I want to be safe when I bicycle. I want to have nice weather and blah, 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 blah. So all of those experiences at this point in time are one type of need. But people also have social needs, which means they want to have appreciation by other people. They want to not be socially sanctioned. So that would be the second type of needs. And then they have values, which are already tapped into earlier, which are like the very basic principles in life they have. So if they think I am a person for whom the environment is important, then the value of environmental protection will need to be satisfied when people make energy decisions. And then depending on how these three types of needs are satisfied in a given situation, people might take action to change their behaviors. And people can take two types of actions in our agent-based models. One is that they do something with their behavior, and the other is that they communicate to other agents. So they can try to convince other people of their position, they can give other people information, they can hear what other people have to say. So the interaction between people is one important part. The other important part is change of behaviors. Next slide, please. So what would happen in our Smarties model is that a person, one of the actors, has a certain level of satisfaction of the different needs at a given point in time and has an expectation how those needs are satisfied in the future, in the next time step in a way. And then this person evaluates if there is a mismatch, if the person needs to improve satisfaction of needs, and then the person takes action. And that could either be changing behavior or interacting with other people or doing both. And that, of course, impacts how other people adjust their behavior and their communication. So if one person communicates to others that, well, it's not really in line with my values to take the car every day, and this person communicates to other people in the network, then maybe they change also their values, or they get reminded that it's also not in line with their values. So this should give you a very, very brief idea of how we think in Smarties that people make decisions. It's of course also only a snapshot of all the different factors that we identified in the ECHOS project that impact people's decisions, but it's a way of simulating complex decision-making processes in larger groups of people. And in the remaining presentations in this session, you will see some more hands-on examples from the Smarties project, and you will also see a discussion about if these types of models would be suitable for being connected or plugged in a way to energy system models. I think the next slide is my last slide. Yes, so I thank you for listening, and I hope you enjoy the remaining presentations.
Fantastic. Thank you, Professor Klockner. I think that was a really great overview of the social science and psychological science side of how people are making decisions in the energy system. We will jump in with our next presenter, Hannes Gaschning. Before I do that, actually, I would remind you, we see we're at about 40 attendees now. For those of you that just arrived, we do have a Slido site open. Go to slido.com, type in the code CITIZEN, and you can send questions or ideas to us and our presenters today. So without further ado, Dr. Hannes Gaschning, he's an environmental scientist and research associate in the Energy Transition Dynamics Group at the Institute of Advanced Sustainability Studies in Potsdam, Germany. As a part of the EU project SENTINEL, he supports developing an open model platform for the European energy transition. Dr. Gaschning, thank you for joining us. For the next 10 minutes, the floor is yours.
Yeah, thanks, Jet, for the introduction, and hi, everyone in the audience. I'm co-leading the stakeholder participation process in the Sentinel project, and I would like to show you some findings from our engagement process today about the user needs of energy models. So next slide, please. So our main question in our work package 1 is what are the specific demands on future energy models by specific stakeholder groups to inform their decision-making process. And here we investigated needs from policymakers, energy industry representatives, including plant and grid operators, people from civil society organizations, and also from the scientific community, so meaning modellers. And we think that this is important to really look into their needs because the literature says, and we also strongly believe, that models that are designed around users and their needs have a higher legitimacy, and they are much more likely to be used in the decision process and fit much better for purpose. So next slide, please. How did we engage these people to identify and prioritize their needs so that we know better what to do first, how to improve our models in the Sentinel project and the model platform that is being developed there better? Here we combined certain methods to arrive at a qualitative and a quantitative overview, but not only an overview of needs, but also to look deeper into those specific needs and to come up in the end with a robust finding about prioritized needs. And here we combined a comparative literature review, a bunch of interviews on the European and national levels in Europe. Then we developed an online survey that was informed by those first 2 steps, but also with input from the Sentinel consortium and our partners. And last week we had a stakeholder workshop where a lot of participants from all those stakeholder groups participated. And from these last 2 steps, we have now different rankings of needs, and we are now going to compare them to really come up with a robust finding. So let's look a bit into these preliminary results. Next slide, please. In the literature review, we used the literature review especially to find some need categories, to really cluster the needs together so we know what is important for the people. And here we especially found 4 categories. First of all, what is not surprising is, of course, the model content. So the what should be modeled, meaning what input, throughput, and output parameters are important in the energy system and its transition, really looking into all the different dimensions that are somehow out there. The second category is the model design and the data, meaning we are looking in the how should the what be modeled. For instance, what is the optimal degree of complexity? How should models be resolved in time and space? What is the best model type? What characteristics of should the databases have, and so on and so forth. And then we came up with two further categories: the modeling process and the model and model platform outreach and communication. I will not talk about this today because I think the audience today is more interested in these first two categories. So the rest of my presentation will focus on those some findings of those two. Next slide, please. So for instance, we have asked in our questionnaire, which of the following factors do you think should receive more attention in energy models? And people had the option to choose from a variety of different aspects, tackling all the different dimensions of the energy transition, and they had the option to choose up to 5 of these options, but also they had the possibility to use the other field, which was a free text field, to give their own ideas of what should be modeled more. Next slide, please. And on top of this ranking, we find what is a bit surprising also for me, that the impact on the environment and natural resource use should be modeled better in the coming or the future models. And we also found this in the interviews. Oh, sorry. I'm still there. Oh, sorry, I clicked on the wrong button. Okay, let's go on. So for instance, a Polish policymaker said there's also a lack of such a model that would assess the overall costs for the environment. Or a Swedish consultant said, what are the environmental consequences of a large-scale use of renewables? So really, these are the driving or the urgent questions of stakeholders today. Next slide, please. But also, social aspects are ranked really high. Almost every second participant in this question said that behavior, lifestyles, and heterogeneity of consumers should receive more attention. For instance, an EU industry representative said, I would say that modeling of social behavior might be very relevant for modeling potential outcomes, but also the social impact of the transition, for example, with energy poverty or distributional impacts, was ranked really high. Next slide, please. But also the economic and technical dimension was perceived as really important, especially here with a extended perception of costs, including external costs, was important, and also the innovation perspective, so the development of new technologies and services. However, I think that you have specific models that you work with, and not all of these dimensions are relevant for all your models because they have a specific purpose. They look in all these aspects from a specific angle, and so not everything must be included. So I also have included in this presentation some findings from the model design perspective, which I think is really interesting for all of those models. Next slide, please. And here we came up with different trade-offs in modeling. On the one hand, we have real goal conflicts. So in which direction should your model be developed? but also somehow time constraints, meaning that you only have limited women and manpower in your project, but that there are so many possibilities to produce results. And so you also have to decide what results you should produce. So we included in our survey this question: which model feature quality is more important to you? And we had a Likert score where people could show high preference or low preference for one of those options. And so we found that for most of these trade-offs, next slide please, there is a clear tendency towards one of those options, meaning the majority prefers, for instance, open source models, fit for purpose models, forecasting models, and so on. But on the other hand, we also found that for some really basic decisions in modeling, like the question, should it be simple or should it be a complex model? Should it be an optimization or a simulation model? Or should we focus more on policy options? So finding the right policy options or finding the right targets, climate and energy targets. It's not really clear. There is no majority for one or the other option. But for the other trade-offs, we found some tendencies, I'd say. Okay, thanks. Next slide, please. So these results, but also other results, were input for our interactive online workshop that we had last week. I cannot really tell you much about the outcome of this workshop. Currently, we are collecting all outputs, documenting them, and try to analyze them, as we had plenary and some breakout sessions focusing on the different model types that we have in Sentinel. But we are now going to write a deliverable that is due in November this year. So I hope we can provide you with more information soon. Next slide, please. So maybe to wrap up my presentation, some conclusions, or let's say more hypotheses, because it is just preliminary results that I can show you and not really a robust finding. So in the model content, there are a lot of challenges that are still remaining and need to be incorporated in models more. And from my perspective, now really begins the wicked work, because more and more people say that the socio-technical transition is important and not only techno-economic aspects. And also we have new ecological challenges to be tackled. And also those needs are also closely followed by expanded cost perception and new progressive technologies that should be incorporated in models. And on the other hand, we have here designed trade-offs, and they are really everywhere in modeling. And I hope that the survey results, also on this aggregated level, can help you somehow to find better, to make better basic decisions, to really fit your models to user needs. And here we, for instance, find that the majority prefers existing, fit for purpose, realistic open source models and comprehensive, progressive and 1.5 degree Celsius scenarios compared with less progressive scenarios. So thanks for listening. I hope the results that I showed you are exciting for you to some degree. We are now going to analyze them further and also to incorporate more differentiated discussion, especially looking deeper into those different stakeholder groups and see whether there are differences in their priorities. And yeah, if you would like to read the report, we will put it on ResearchGate, but also on our Sentinel project website and on our personal employee profiles on the for instance, the ESS website. Okay, that was my presentation, and thanks for listening.
Great stuff, Dr. Goshning. Thank you very much for joining us. Obviously sharing a different and very relevant perspective about what do people actually need out of these models. Also, there was a strong link with what we saw in plenary 3 this morning, where some new models were actually considering some of the issues that you raised and that your stakeholders raised, especially what's the impact on inequality, energy justice moving forward of different pathways. So I think it's a positive thing that we are making some progress on some of these needs. So please submit your questions to Dr. Goshning on Slido with the code CITIZEN. We will now move on to Dr. Gujarro Berdinas. She is a member of the Smarties Project, holding a PhD in computer science. She is an associate professor at the Faculty of Informatics at University of A Coruña in Spain, and a member of its laboratory for R&D in artificial intelligence. Very happy to have her with us today for the next 10 to 15 minutes. Berta, the floor is yours.
Thank you, Jed. Good afternoon, everyone. In my presentation, I will talk about some basic concepts of agent-based modeling, and I will use one of the cases from the H2020 Smarties project to illustrate some of these basic ideas. Next, please. We all know what a model is. It is a simplified and purposeful representation of a real system that we create with the goal of answering questions about that system, understanding how things works, explaining some behaviors, or even making some predictions about them. What I would like to emphasize here is that agent-based modeling does not differ from other, I would say, more classical approaches, and therefore the words simplified and purposeful are also key questions. Next, please. In agent-based modeling, a system is described from the perspective of its constituent units, and in short, it's modeled as a collection of autonomous decision-making entities called agents. Each agent individually evaluates its situation in a given context and makes decisions following some rules that define its behavior. They may execute several behaviors according to the system they are representing, like, for example, selling, producing, consuming. And what is very important, they interact with each other. An agent, for example, could be a star in the sky, a vehicle in a transportation network, or a citizen. Next, please. The H2020 SmartGate project, as Christian already told us, studies how the roles of various stakeholders influence the dynamics of social innovation using 10 cases of social innovation across Europe. The main objective of the project is to try to understand how, what are the mechanisms that facilitate the acceptability and good reception of this project by the citizens. We have, for example, the case of a closure of a park to traffic in Groningen as part of a mobility plan, the case of the Scottish Energy Efficiency Programme to improve the situations in areas with energy poverty in Aberdeen, that my colleague Gary Polhill will present next, or the case of the creation of superblocks in Vitoria in Spain, which is the case that I will use as an example throughout this talk. Next, please. The project of the superblocks of Vitoria tries to reduce the space for cars and recover the space on the streets for people. A superblock is an area of the city free from passing traffic. It is surrounded by roads where perimeter traffic is allowed, but inside is only allowed in the form of loops, so that the cars that enter are again expelled to the perimeter roads. They also have some other internal restrictions, like the type of parking that is allowed or the speed limit of only 10 kilometers per hour. Next, please. To get a simplified and useful model, it is crucial to have very clear which is the model's purpose, which is the research question that we want to be answered through the model. This question will guide us as modelers, so we can know which details of the real system can be filtered and which cannot. For example, next please. If we want to create a map of London, of the London Underground for an engineer, surely the first map on the slide is the correct one. But if our objective is the user of the underground, then we must dispense with many details that not only do not provide any useful information, but unnecessarily complicate the use of the model. Establishing the research question is an important task that may seem obvious, but it can be very difficult for a complex system. In fact, in the smartest was. Since this question determines the target of our model, it should be step one in its development. Next, please. Going back to Smarties, the question could be understanding citizen acceptance of certain social innovations to study their upscaling and replicability. This is a very good objective for the project, but this is not a valid research question for a model, because how can we measure that? We must be more specific by asking, for example, in the case of Vitoria, what percentage of citizens will be in favor and what percentage will be against superblocks in a given policy scenario. With this question at hand, we are ready to go further. Next, please. The next thing we must do is to identify which are the important actors to represent in our system, that is, our agents. The first formulation can be based on our preliminary knowledge about the system to be modeled, some empirical knowledge, theories, previous model, or even our imagination. Next, please. In the case of the superblocks of Vitoria, we definitely identify the citizens as main actors. But since we want to know their point of view or position about the superblocks, we need to model some other actors that influence on that position. For this reason, we have also included the city council, the press, and some relevant associations that play the role in Vitoria, such as neighborhood associations and an association of cyclists. Next, please. As a third step in the development of the agent-based model, we have to put our agents in a virtual environment and decide how they interact in that environment. We have to ask what processes are essential to our problem, what factors are of great influence, how do they affect agents. Next, please. If we turn back to the Vitoria case, as I was saying, we are interested in knowing the position of the citizenry regarding the creation of superblocks. And one of the main issues that influence the position of the citizens is the opinion of others. Therefore, it is necessary to define the social network of the citizen agents, which will be made up of friends, family, co-workers. We need also to define the main process that they can carry out in our system, what agents can do. In our system, the agents can communicate. This will be the main process, communication. The agents will be able to communicate their point of view to other agents, as well as ask other agents for their opinion. Next, please. Once we have made our simplified assumptions to represent our system, we are clear about what agents we have and what they can do, in our case, communicate. It is time to go through the details. What are their state variables? How the agents behave? Next, please. As Christian already told us, as the Smarties, our citizen agents follow the HUMAT architecture that has been defined as part of the project. This architecture is inspired by social scientific theory and links agents' perception, motivations, decision-making, and communication. In this model, each citizen has 3 categories of needs. Just to remember, they have experiential needs, for example, related to comfort, such as I want to get to work quickly. They have social needs related to feeling accepted or maintaining a social status. And the values that an agent has, such as I don't want to use forms of transport that contribute to ambient pollution. When an agent is faced with different behavioral alternatives, he chooses the most satisfactory one with respect to each of the 3 blocks of needs. Next, please. However, sometimes they do not have a clear alternative that produces satisfaction in the 3 blocks of needs. When this happens, a cognitive dissonance occurs. It would be the case, for example, when a person does not want to use means of transport that favor environmental pollution, but on the other hand, he wants to get to work quickly, and that leads him to use his own car. When a citizen, an agent citizen, experiences a high cognitive dissonance, it follows some strategies to reduce it. It depends on the needs that is not satisfied. If the dissonance is related to social needs, the agent sends its opinion to the citizens on its social network to convince them to reach the same decision. On the contrary, if the dissonance has to do with the values or experiential needs, then the agent inquires the other agents in its network to know their opinion, and with the possibility that they make him change his mind in some aspects. Next, please. Regarding the other type of agents, which we have called in our model critical nodes, their behavior is less complex. Their position is static. They always defend the same position, the same opinion. Their role is to try to influence citizens, and for this, the critical nodes will communicate with them when they detect certain levels of oppositions to the point of view they are defending. At the end, all this communication to exchange opinion between citizens and also between critical nodes and citizens is what will allow citizens to evolve and change their positions over time. And this evolution is a phenomenon of our interest. Next, please. In developing our model, there are many other details that must be taken into account in order to have a working model. Many issues that I don't have time to address in detail, but that are also very important. For example, one of the issues is how to give values to the variables that intervene in the model, and that we will do it through data collected with surveys, with social demographic data, press reports, etc. Another important issue that we are now working on it is to know what alternative policy scenarios could be defined, which are the parameters that define the different policies. And there are many other questions, many more questions, like how to deal with trust between agents or how they are easily influenced. Finally, some of these variables of the model will be parameters that the user of the model can vary in order to experiment with different realities that in turn could lead to different citizenry behaviors. Next, please. Our final goal with the model is to create models that capture the essential causal mechanisms of the social system. If we are able to reproduce the empirical reality, later on, running these models under a variety of initial conditions will allow us to explore which different futures are more or less likely based on different conditions and policy scenarios. Ultimately, these models will allow us to learn from success, to understand how public policy developments and community dynamics interact, so that we can identify the risk of failure and mitigate it at an early stage in our future projects. Next, please. If you want to learn something more about the SmartTeach project, you can visit the website or our Twitter. or you can also write me an email. Thank you.
Thank you, Professor Bardinas. I thought that was a really fantastic distillation of an agent-based model and how you go about developing it. We will jump right into our next presentation, just going a bit more into the nuts and bolts of agent-based models. Please, for these two presenters, if you have questions for them, go to slido.com with the code CITIZEN. You can leave us questions with which some people have already done. And for the next 15 minutes, Dr. Paul Hill, I will hand to you after a short introduction. Gary has been working in agent-based modeling since 1997 in land use, energy, and crop research. He's a project leader at the James Hutton Institute, and he has worked on many agent-based models in the past decade, including as president of the European Social Simulation Association. Please, Dr. Paul Hill, the floor is yours.
Thanks, Jed. Okay, next slide. So I was asked to talk in general about linking, or the potential for linking some of these agent-based models that Berta Guijarro-Bardinas just described. And my starting point would be to make some general observations on linking models together. So firstly, in the ideal world, we're thinking about the linked whole model that we're trying to create. That would ideally be the model that you would have built from scratch if there hadn't been any other models already that you wanted to couple together. That's the ideal, but it, I guess, rarely is the case. There would always be bits of functionality you need to add or take away in order to get what you want. But what's absolutely critical, what cannot be ignored, is that the linked whole model must be consistent. Everything that goes on in that model must be non-contradictory. And models have so many components and parts and ideas that drive them. And there are various ways in which that cannot be the case. The most obvious one is that the same things must happen at the same place in the same time. So you mustn't have contradictory events going on in the model. Ideally, it's not actually necessary, but if it's not the case, then a lot of work is needed. You need to have compatible spatial, temporal, and organizational scales. You also need a similar level of abstraction. So going back to the example in the previous presentation of the London Underground, you know, if we have a level of abstraction that corresponds to, let's say, the simplified map, and we want to couple that with another model, but let's say for some reason, I mean, it doesn't make any sense, but let's say we were trying to couple it in a kind of metaphorical sense with the Paris metro. A very, very detailed map of the Paris metro with every track marked, every power line would be an issue. Another thing that I think often receives rather less attention, partly because I think we rarely find ourselves in the time to reflect on it, is that underpinning theories bringing the model together should not be diametrically opposed. You know, there are philosophical positions in science and in the individual disciplines, and especially when we're coupling social models with physical models, we need to be cognizant of the different kind of philosophical perspectives that people are bringing to the simulation of the system. A lot of these issues with consistency have in fact been given some attention in the computing science literature under the heading of semantic heterogeneity. These often arise from trying to automate the process of bringing employee databases together as companies merge and split off and all this sort of thing. And it has been clear that a number of conflicts in the way in which data and concepts and ideas are represented are categorized. So, for example, you can have naming conflicts, which occur when, for example, you might use a different name for the same idea or the same name for a different idea. So, for example, you could talk about the status of a person. You might mean the marital status, or you might mean the employment status. Scaling conflicts might occur when you use different units to represent the same idea. There can be other kinds of conflict as well, to do with the way in which things are represented. So, for example, you could represent someone's name just as, full name. So you just have one word for it, or one field for it in the database. And then you might have two fields for their first name and their last name, and you might have another field even for what they're known as. The computer scientists had this great hope that they would be able to solve all this automatically using metadata. But as the sort of right-hand diagram illustrates, even if you label the things you're connecting, you can still end up with a whole that doesn't make any sense. There's a classic issue that can occur when connecting social and technological or biophysical models together, really due to the much more significant pedigree and history of providing models in the biophysical sciences. So, for example, you might model every last drop of water in a river basin every millisecond. But because we've not got so much experience or history of modeling social systems, you just have something very crude and simple modeling the whole social system. Voinov and Shugart have an article in Environmental Modeling and Software with the wonderful word integronsters in the title, which is a concatenation of integrative and monsters. And a bull in the china shop metaphor is what they use to illustrate this concern. Next slide, please. I wanted to emphasize just how important openness is, and it was interesting to see from Professor Gashnick's presentation that this was, there was non-uniformity, shall we say, in opinion about openness. When linking models together, if we treat them as black boxes, there are issues that can occur. And I'm going to give you an illustration from my own work. I developed a model called Fearless, which simulated farmers making choices about what crops to plant and trying to stay in business as the climate and economic conditions affecting how well they did changed. So I could produce a map of land use in an area, and then my managers were very excited about the idea of feeding this into another model called CAMEL, which simulated phosphorus flow through the landscape. Phosphorus is a highly soluble chemical that's used to fertilize fields, but it has some very interesting dynamics in that it can sort of build up in the soil, and then when there's a heavy rainfall, suddenly all wash out into the water streams and create algal blooms. So it's an important environmental problem. And the idea was that I would send CAMEL a map of land use. CAMEL would tell me the phosphorus runoff, and then I would use a government incentive agent in Fearless to try and incentivize the farmers to manage their land in ways that reduced the chance of these environmental consequences. Now, we didn't talk to each other very much for various organizational and interpersonal reasons. And I'm afraid the result was a little bit concerning. We both had to have a crop model inside our models, and we hadn't told each other about it. my colleague developing the camel model needed to have a crop model because a critical part of the flow of water through a landscape is something called evapotranspiration, which is where water is sucked up out of the soil through the plant and evaporates from the leaves of the plant. And because his model operated at a very fine time scale, he used a daily climate time series to simulate that. In Fearless, I just needed to know what the yield was at harvest, and the prime determinants of that are a kind of yearly climate time series that tell you what the length of the growing season and the length of the harvest season are. And these are the chief determinants of yield. Now, if we hadn't told each other about this, I mean, unfortunately, after we developed the models together, we wouldn't know. And there is nothing stopping a bumper harvest and a massive crop failure happening in the coupled whole at the same time. And so I want to emphasize this point that we cannot really scientifically link black box and proprietary models. Next slide, please. Thinking about other areas where agent-based models might clash with models, agent-based models typically take a complex systems perspective where we have heterogeneous interacting agents and out of equilibrium dynamics. So if your model assumes equilibrium, then we need to talk about how we're going to finesse that when we couple them together. We can have, we usually or typically, that we don't have to have, heuristic and cognitively or psychologically plausible decision-making algorithms, such as HUMAT described earlier. Again, if your model assumes or needs to assume that humans are rational and optimize their decisions, then we need to have a conversation. Agent-based models are spatially and temporally explicit. We need to know what happens where and when. If your model covers a whole system and doesn't break it down, again, that might be an issue. Models are also non-deterministic. They often have stochasticity in them, and that can affect their dynamics. And again, that can affect your ability to couple with other people. We also have discrete populations and time and place, and discontinuities in algorithms used, for example, with rules where we use if then else kind of statements to decide what happens. And this can be an issue coupling with differential equation models if you need a sort of differentiable surface to try and optimize them. Next slide, please. I also wouldn't want to pretend that agent-based modeling was a well-established discipline with you know, a set of standards and methods that can just be rolled off the shelf. Agent-based modeling needs investment in order to develop these kind of more established methods. I wrote a paper in Geoinformatica that outlines sort of various scientific research agendas that are needed to make that happen. They also have high data demands if we're operating in empirical context, because we need to know what individual people do and what they think and how they differ and how they influence each other. And we often don't have access to that kind of fine-grained data. Again, these things can be finessed, we can deal with them, but you know, it's important to be aware. The other thing is that if we wanted to do large-scale models, especially, let's say, across the whole of Europe, there can be significant computational demands. To handle the stochasticity issue, you would often run a model several times under a single setting anyway. But we have lots of parameters, so there can be you know, lots of different combinations to try. And well, we would typically find that on a single computer, you couldn't comfortably run a model, let's say, of 10 to 100,000 agents. So running a model for, I don't know, 150 million agents, which is possible, is not technically trivial. They can generate an awful lot of output. So even once you've run the model, processing those outputs can be demanding. And this makes, that same reason, makes communication and visualization challenging. We're also a very cautious community about interpreting our models in a predictive way, partly because of the complexity. of the systems we're studying. Next slide, please. However, we have the potential to bring quite a lot because we can simulate some of these social behaviors. We can simulate the emergent dynamics of people interacting in their everyday lives and adapting and changing to new infrastructure and new constraints and work on their life. And I've put this graph here, which is a capture of the frequency with which demand for energy in houses measured with very fine-grained data. I think it's 1 minute loads in this paper by Wright and Firth in 2007. And you'll notice that they're heavily right skewed. So although your mean load is is around, well, it's 0.8 of a kilowatt there, the maximum load is 9.3 kilowatts. And these kind of fat-tailed distributions are what we classically observe in complex systems. Agent-based models are very, very good for handling some of that complexity. But our agents don't have to be humans or individuals. We can also simulate energy companies trying to make investment decisions in infrastructure, trying to compete with each other for customers, and even competing with each other in a marketplace for energy. We can also simulate local, regional, and national governments, adapting and changing policy in the light of observations they make of the system. Next slide, please. There are various modes of coupling, and really all I wanted to take away from this slide is that although it's ideal to have a full feedback loop from an agent-based model back to the system, it's not necessary. You can just use models to create scenarios. You can then use agent-based models to provide scenarios for a system model and vice versa. So next slide. So really, to summarize what I've said, linking any models together, you need to be absolutely sure that there is a consistency in scale, level of abstraction, and an awareness of the issues associated with semantic heterogeneity. Linking with agent-based models, you need to be aware of their complex systems perspective, their demands for data, and that there are several different options for coupling. I think that's my final slide. Yeah, thank you.
Fantastic. Thank you, Gary. It was really interesting to see that issue of linking agent-based models with energy system models discussed so plainly. In the intro survey that about 35 people took, we saw that everyone's rather strongly agreed with the idea that agent-based models can and should be linked to energy system models. And I think, Gary, you just showed us why that hasn't happened on the large scale yet, because there's a lot of complexity there that we need to figure out moving forward. So we're happy to have this.
It can be done, but it needs work.
Yeah. Great. So I will hand over to our moderator for the next 30 minutes of discussion, who will invite you to do a post-presentation survey that's now live on Slido, Diana Susser from the Sentinel project.
Thanks, Jed. Yes, thanks to all the speakers. I think that was really a nice series of presentations, like coming from the need of stakeholders to better integrate behavior, heterogeneity, in models, like then having the examples from the Smarties project, how this could be actually done, and then facing also the challenges of how we could potentially integrate ABMs and energy system models. So just a quick reminder, please take now part in our pre-survey. Our pre-survey is now online, so just go to slido.com, use the code citizens, and please respond to the questions you are seeing there. Also, keep going posting questions. We will change in a bit to the questions we got already, but please feel free to approach our different speakers. Please also ask other questions related to the survey if you want. And yes, so that's I think what we're going to do now in the next 20 minutes, 25 minutes. So maybe let's just have a look what kind of questions we got for our speakers. Jeff, would you be so kind?
Yes, let me see if I can do that. Here we go.
Perfect. Actually,
and maybe if we want to have a panel environment, maybe everyone can turn on.
Does it work? Yeah. So, okay, we got only 3 questions so far, so please keep asking questions. The first actually came from myself, so I'm quite keen to learn more about opportunities of how to integrate agent-based models and system models. I think we heard already about the challenges, but maybe there's more to discuss how this could be done, maybe also in terms of like discussing, maybe also just results together, but not trying kind of to link specifically those 2 kind of models. Then we have the question regarding the open source models, that there are many out there already, and if there would be not time to focus more on collaborative work. I think we had a quite nice example here from Gary, right? It showed that he developed something together with another colleague, and then they started just talking at the end. So maybe some perspectives here, how this could be done, and maybe again also the question if there's also some way maybe to start a collaboration between an agent-based model development and a system modeling from the beginning. And then another question like the HUMAT framework we got introduced to from the Smarties project. So what is maybe the social psychological foundation of these models? Can you maybe say something about this and the basic values? So maybe we start with these 3 questions. Maybe all of our speakers can come back with video, and also unmute yourself, please. It's good to see you back all here. Who wants to start first?
Well, I could say something to the psychological background of the HUMAT model. It's not one psychological theory. There are a number of theories feeding into this model, among them being dissonance theory that was mentioned by Berta in her presentation. There are some theories around need and need satisfaction that we put in here. So what we did is try to identify specific mechanisms of how people make decisions in a number of psychological theories, and try as mechanisms that can be formalized. So that was like the driving factor here, because we should be able to program them into like the decision rules for the agents. So we had theories about how social influence changes parameters in people. We used theories about how people handle cognitive dissonance. We have theories how people make behavioral decisions, and how you would put quantitative values on these different aspects of the equations that in the end come out of this.
Okay, very interesting, Christian. Thanks for the insight. Maybe then, like regarding this, like just a question back. So, how do you actually then value the different factors that lead to the decision making in your model? Like you said, there are different factors influencing decisions, but how do you decide which value you give to which one?
What we do in Smarties is a combination of different techniques. One is that we use existing data sets that have measured some of the parameters. We have also done surveys with the relevant populations to get like starting values for key parameters in our models. But some of them are also based on assumptions that are fed by theory rather than like empirical data. But what we try is that we base our models as much as possible on empirical inputs. But then, of course, when you look at how models develop over time, you can validate them against historical data, but you cannot validate them against, well, you can, of course, if you model something and then wait what happens in the future, you could also validate them against future data. But what we use is usually data input from one point in time. Sometimes we have also longitudinal data that could be used there to get a feeling for how things develop.
Okay, great. Thanks for the insights. Maybe Berta, do you want to add something on that? Maybe also addressing the challenge of the data set that somebody asked here. What data sets are you using? Maybe can you report a little bit from your project how you go about this?
For me, as a modeler, the more difficult part was to establish a relation between the 3 blocks of needs, because I'm not a sociologist, and the variables and the questions that we do have to ask the people, the citizens, and to link together with the policy scenarios to know up to which point the certain policy is related to my needs as a citizen. So this was a very difficult part, at least for me as a modeler. But and I think is a step of the model that takes a long time to get to a good questionnaire, to a good survey. And this is a very, very interesting question: how to give values to these needs.
Okay, thank you. Hannes, Gary, do you want to add something from your side?
Not on that specific topic, but certainly I can respond to Tom Brown, the anonymous person, about open source models, and Daniel Hookman as and when called upon.
Sure, please go ahead.
So in terms of validation, to take that question first, there is a lot of work on validation of agent-based models. One of the problems actually is that most of the techniques for validation are designed around traditional or more established, shall we say, modeling approaches, and so are chiefly quantitative. But this does not tell the whole story of what an agent-based model is doing. If you imagine the approach, let's say in classical statistics, of getting a data set, fitting a function to that data set, and then measuring your error from that function, that is very, very different challenge, if you like, in agent-based modeling, where you're trying to generate that function as an emergent property of the interactions a layer down. And in other words, to kind of do justice to what agent-based model is doing, you not only need to look at quantitative validation of the whole system, which does go on, but you also need to sort of validate the ontology, validate the structure of the model, what goes on in it. And that's often done through sort of expert processes and more qualitative methods. We are still, I think, not at a point of having standardized set of methods for sort of, shall we say, I would describe it as developing confidence in what the model says for various different purposes. So I think, I mean, it's an important question, but a lot of work is done on it. I just don't think we've finished that work yet. In terms of the open source models out there already, and whether it's time to focus on collaborative work now, for me, the models that are out there already, I'm actually involved in a meeting going on today about Open Modeling Foundation, the formation of this. It's an American-led initiative from the National Science Foundation. And this question of model reuse is very, very difficult, especially in social systems. If you think about it, the way we conceptualize and describe social systems, however much we may try to be objective about things, there are cultural, social, linguistic factors that determine what we prioritize, the way we conceptualize things, and how we might represent them. And so this means that actually it's not necessarily appropriate to take a social system model from one place and apply it in another without actually going back in, talking to the key informants in that area, asking yourself whether you really have conceptualized that model in an appropriate way. But focusing on collaborative work, I mean, absolutely, this is vital. It's vital for two reasons. Firstly, because we need to overcome this impasse in how we get models to talk to each other, which is partly a technical issue, but is also partly a cultural one. But also, I think modeling, as Hannes was saying, is a social process. So people need to be involved in it, not just the modelers going away and hiding in a room and coming up with some magic little black box later, right? You need to be involved in it because you need to understand what's going on. And finally, as regards work going on to try and ensure consistency and completeness? Yes, there is. There are various authors in Europe, and there have been work, particularly in a project called Seamless, it's very famous, on trying to do this. It can't be automated. That is the essential outcome of that work has been that this process cannot successfully be automated. It needs some kind of human oversight. That's me.
Thanks, Gary. Great insights. Something from the others to add on the points to validation, or potentially also how we go about the integration or the linking of agent-based models and system models in the future. Not specifically, Christian, maybe you want to share more some insights from the Smarties project, how you do this, how you deal with openness there. Is your approach open, and do you think it could be easily also applied in other areas, for example? Or how do you think about it?
Well, the interesting thing is that in Smarties, we meet the same kind of challenges internally also, because the structure is that we have 5 different case clusters and they have different types of models. And in each case cluster, we have a leading case and a case that is somehow similar for which we develop the models. But we also have a follower case where we try to find out if models that have been developed in one context can be transferred to other contexts without having to start from scratch again. And we don't really have an answer to that yet. So it might be that by the end of the project, we find out, no, it's not possible to do that meaningfully, but maybe we find a way of doing that. So yes, openness. At the moment, we are very open within the Smarties project between the different modeling teams. We have 3 teams working on models at the same time. But of course, the more the models develop, the ambition is also to make both model code, but more importantly, the methodological advances behind open for the community afterwards, so that it can be used on, and that parts of our, like for example, if you think the HUMAT idea is appealing, that it will not be kept a black box. It will be very open what goes in there in all our 10 applications or 15 applications of it, and that should lead then on to that it can be used further and adapted and also validated. And it might be that some people find in the future that some assumptions that we put in are not valid, or at least not in all contexts.
So just to follow on from that, I mean, to make it concrete, the James Hutton Institute is modelling, among other things, the case studies in Timisoara and Aberdeen associated with joining a heat network. Now, in Aberdeen, this question of whether you trust people telling you to join a heat network is important, but not as critical as it is in Timisoara, where there have been, you know, some kind of difficult history around the heat network and the way in which it's managed and run. That means that there is a significant trust issue, and so we need to be able to model the dynamics of trust and how we might change it. Something we don't really need to do in Aberdeen. So this means that, you know, whilst in essence the model might be the same, there are, even within this is even before we've gone to a follower case studies, there are small differences from one case to another.
Mm-hmm. Thanks for sharing this insight. I think that's yeah, definitely a challenge, and also like comes what you say, right? Societies are different, transformation processes in different regions are different. Therefore, we have to be quite sensitive with yeah, the transformation from, or the application from one to another area. But I think that's also one of the reasons why is it also so challenging, right? How to connect it actually to the energy system models that are out there. I mean, we have a lot of other sessions where we talk about this highly complex energy system models that they often neglect kind of the different actors. So the question is, if you look more on the decision making, on the policy making level, what kind of perspectives do you see? How do we need to think agent-based models that I personally really like, because they really bring this bottom-up, emphasis into the whole debate, and how could we better communicate them, work them together with existing energy models. Do you have any perspectives on that, how we should go about it?
Well, I feel kind of tempted to answer a little bit, and then I'm sure Gary will kind of disagree afterwards.
That's good.
Because
That's
we
what
have
we want,
these
right?
discussions. We have these discussions in Smarties all the way. Me not being like a modeler, but rather a psychologist, I was going to Smarties with the assumption that we would, in the end, come out with a sandbox tool where policymakers could go in and switch on and off certain variables and fool around with the model, and then get some ideas how their policies would affect behavior in the future. And since we started with Smarties, I have learned what Gary also pointed out today, is that agent-based modelists are very, very careful not to be understood as people with a glass bowl to look into the future. So what we can provide with agent-based models is a tool that can explore likely variations of a scenario. So we have assumptions that are based in empirical realities. And what we can do is that, given these assumptions and given our models are correct, we can explore what could be likely variations of that alternative of that reality if you change something of the policy making. And this is what we are now working towards in Smarties as one of the final big outcomes, that we are both trying to develop a tool that makes exploring such alternative versions of realities explorable, easily explorable. But on the other hand, we also say that, well, if you really want to go into depths, this cannot be done just online. So there we would say that then you would need to do a more in-depth workshop with our modelers, where we take in the local context better into the models, where we explain what is happening, where we explain more what the assumptions are that go in here, to prevent this assumption that this is a perfect tool for predicting the future. And how would you connect that to energy systems models? Well, I would say that the models are so different in the like level of abstraction, that I would rather say that agent-based models give you a taste of the heterogeneity that you need when you think about consumers, for example, as one role, one agent, but also other types of agents in the energy systems models. And maybe a first step would be that these models learn to talk to each other in a way where agent-based models give some kind of aggregated scenarios into energy systems models, and the other way around, that energy systems models could help agent-based models to define the context they are operating in more dynamically than they do now. So now agent-based models would basically treat the energy system as an unknown context around that has a certain status.
So I'm not.
Yes, quickly answer this, please. Yeah.
Yeah, I'm not going to disagree with Christian.
No.
So that's good. I would emphasize that I would see this version where you can see what we've done as more like an advert for the in-depth full process where we collaborate with you on a model. And this then leads into this question of the concrete linking of ABMs and energy system models. I wouldn't link them together for the sake of it. I would link it around a question that needs to be answered, and let that question, that problem, drive what you do. And be ready that both the energy system models and the agent-based models that we might bring to that collaboration might well need some adjustment to make that happen. So you don't link for linking's sake. You do modeling because you have, well, it goes back to what Bertha was saying about, having a purpose in mind. And so you let the question and the purpose drive what you do.
Thanks, Gary. Great. Maybe then also back to Berta. Do you want to say something before we look to the polls? Maybe some final insights, impressions, feedback from your side to the others.
I agree with both Christian and Gary. I don't think there is a line to say what the steps do you have to take to link AVMs and system models. It depends on the question you have to answer, and it depends on as Gary said, on how your model, your agent-based model and your system model does, and how they have to collaborate to answer the question. There is no magic trick to link them. I'm sorry.
I didn't expect that, to be honest, but thanks for pointing it out again. But yeah. So Hannes, some last words from your side before we look to the poll results? Anything you want to share?
Yes, maybe to this one point about the collaboration again. Well, the point that I want to raise is somehow linked to this, but not it does not really match one by one. So what our results in these trade-offs showed somehow is that people would like to have less models, but with a large community in these models, so have a lot of expertise and not so much a variety or a large set of quite equivalent models, but a lot of them somewhere out there. So somehow to reduce the amount of models that are existing. And probably this is much more difficult for this social dimension because it's really, well, you have to fit it to the context of the specific situations, but maybe it's easier for this techno-economic models. So, and I don't know, maybe there are some measures out there that could help to reduce the amount of models and to grow more elaborative model communities, but I don't see it coming. You know, there is still new funding for it. Those people who fund the models do not have the overview. Somehow the guidelines must change. I think this is something that maybe should be emphasized somehow. And also on the last open model conference, one of the keynote speakers said, okay, maybe we should collaborate more in this specific aspect, and I don't know, let some models go somehow. I don't know whether this is a thing that should be discussed more, maybe also in this setting here or somewhere else, but I think it's an important issue, especially when you look on the survey results.
Thanks, Hannes, for sharing these insights. Unfortunately, we don't have time to discuss it in this session. It doesn't mean it doesn't happen somewhere else. I think it's quite a progressive statement, but I think it's a nice conclusion in general that, yeah, collaboration is important, like among the AVM community, but also with other, yeah, with the energy system modelers. And that addressed also like the first question in the survey we actually gave to you. Can agent-based models be coupled with and add value to energy system models? And the majority, 42% of the respondents agree that they can add some values, AVMs are useful. So that's kind of a good statement for this, besides all the challenges yeah, we might face in the integration, as we learned today. Let's have a look to the other questions we received. Should agent-based models actually be coupled with models? Still, I think that was also like, there was a high agreement also before on these questions, and it's still high. So even we had kind of this critical reflections here on how it could be done. Still, it's, yeah, there's a high agreement, and this should be done. And let's go further with other results. Citizens and consumers should be more actively engaged in the energy modeling process. So here also like kind of coming back to what we have seen before, like some agreement, but also some mixed feelings, some people that are unsure about it. I think, yeah, Hannes didn't show the results here from the Sentinel project today, but I think there is some room for improvement. And I think he kind of nicely showed that it might be actually quite important to engage them here to some extent at least. Do we have another one? Data availability and or data quality are major roadblocks to better representation of consumer citizen behavior in energy models. I think that's also something we picked up from the morning session. And also here we have like with over 50% a strong agreement that this is a bottleneck. Maybe not only the data availability, but then also the question again, like on how to integrate the social scientific data into energy system models. So maybe giving also some additional value to the agent-based models that exist and yeah, get further developed. Great, I think that's it, no? Do we have another one, Jed, or is it the last one?
No, that's it. We are
That's it. Perfect. Great. Then
a couple minutes over time again. So
sorry for that. Yeah, you can close now, please.
all right, well, thank you all. Really appreciate it. Thank you to the speakers. Thank you for the participation in the surveys. We'll go through that in our report that we write up about this. I thought it was interesting that people actually got a little bit less optimistic about joining agent-based models to energy system models. I thought it would be the other way around, but I think seeing the reality of the differences here was a bit striking. So hopefully we can move forward from there and find ways to overcome some of those complexities. So thank you again to our speakers, really appreciate it. Thank you, Diana, for the fantastic moderation, and enjoy the rest of the conference all. Goodbye.
Thanks to you, bye.
Thanks, Jed. Thanks, Diana.